Okay guys, so the topic that we're going to be covering today is matrices, and unless you're on AB, I'm pretty sure you haven't touched that since Algebra 2. So let's get started. We have a bunch of topics we're going to be covering today, such as adding and subtracting, multiplying, the determinant, inverse, including doing 2 by 2 by hand, and then everything else with a calculator, and then basic matrices algebra. So let's get rolling, okay? So adding and subtracting is super easy with matrices. So here I've set up the basic formulaic example with the red pill and the blue pill. Matrices pun. Okay, get it? No, okay. So basically you just add or subtract straight across. The A goes with the A, and the B goes with the B, and the C goes with the C, and the D goes with the D. If you have a larger matrix, it works with the same concept. But this is the formulaic example, and it's pretty straightforward. Okay? So multiplying matrices is a lot harder than adding or subtracting matrices because there's several rules involved in it. So in general, matrices are written as number of rows by number of columns. And because multiplying matrices is not commutative because of what I'll go into, there are specific ways in which you have to do this. Okay? So when you write out the dimensions of the two matrices you're going to multiply in the exact order, the insides of the dimensions that you just wrote out, as I circled up above, have to match. And then the outsides, what you haven't circled, or what I haven't circled, are what your new matrix is going to look like after we multiply. Okay, so when you're multiplying matrices, think of it as a train, okay? So the first row of the first matrix is going to go chugga 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 choo choo over to the first column of the other matrix, okay? So now we have to make sure our train lines up with our train station. In this case, in our formulaic problem, our B will go with our C and our A's will go together. Okay? And whatever lines up, we're going to multiply. And from there, we're going to add up all of our products, and we're going to put that in the first column of the first row because that's the number we just figured out. And then we get to repeat it for every single column of every single row, where we just bring more trains to their stations and we line them up, multiply them, and add the products together in whatever rows we came together. So now we're going to learn how to find the determinant of a 2 by 2 matrix. Okay? The determinant is just a real number value that will help us find the inverse of our 2 by 2 matrix come later. Okay? So finding the determinant is super easy. Okay? So using our formulaic example of the ABCD, okay, we're going to take the A and the D and multiply them together. Then we're going to take the product of B and C and subtract that from the AD, okay? And then it's as simple as that. That's just your determinant, that integer. That's it. So finding the inverse of your 2 by 2 matrix is actually relatively simple. There's only 3 steps involved. 1, you have to determine the determinant of your 2 by 2 matrix. Let's just call this integer m for simplicity's sake. And then you're going to have to rearrange your matrix. So if we use our formulaic example of ABCD, you're going to rearrange the locations of the A and the D, and then you're going to change the signs of the B and the C. Okay? And then after that, the final thing you have to do is just multiply your new rearranged matrix by the reciprocal of your determinant. Okay? And then this is the resulting is the inverse. And of course, we all know that when you multiply the inverse matrix by its original matrix, then you're going to get the identity matrix. So for finding the inverse on anything but a 2 by 2, we're going to try and use a calculator, okay? So this is actually relatively simple. What you're going to do is you're just going to go to your matrix function, and then you're going to scroll over and edit your matrix and for whatever you have. And then you're going to press second quit, and then you're going to go back into your matrix function. Select the name of whatever matrix you edited. Then you're going to press the X to the -1, and then press enter. And that is literally your inverse matrix. Ta-da! So we're just going to go over some ground rules for matrix algebra because we've already gone over all the components that are involved in it. So there's only a few ground rules. 1, PEMDAS always still applies in algebra no matter what you're doing. Okay? 2, matrix multiplication is not commutative. So if you're multiplying a matrix on the right side of another matrix on one side, you have to multiply it on the right side of the matrix on the other side. No exceptions. Okay? Thirdly, you cannot divide by matrices. That's a no, 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 no. That's why we did the inverse. The inverse is the equivalent of divided by the matrice, because when you multiply a matrice by its inverse, you get the identity matrix, which is just 1. Okay? Other than that, I think we're good to start matrice algebra and start our cupcake quiz. Okay? Okay, so the cupcake quiz is just a review quiz of everything we've learned so far in the video. Okay? We're just going to put integers onto placeholders, which are the cupcakes in these pictures, and you're going to be able to solve whatever problem I'm giving you. Okay? So if you get at least 3 points, you may come up and get one of the mini cupcakes I made from scratch, both frosting and the cupcakes, and we're good. Just make sure you write down your answers to confirm it, and then the answers will be available at the end. Each problem is worth 1 point, and there are 5 problems total. Okay?